Dear students, welcome. This is our 8th class on hydrostatics. Today, we shall find the pressure equation of a fluid, which is at rest under the action of given system of forces. Now, equilibrium of fluids, equilibrium of fluids, which is at equilibrium of fluid, which is at rest under the action of given system of forces. Under the action of given system of forces. Under the action of given system of forces. Now we obtain our aim is to obtain the pressure equation. The pressure equation of a fluid. To obtain the pressure equation of a fluid which is at rest under the action of given system of forces, to obtain the pressure equation of a fluid which is at rest under the action of given system of forces. First of all, suppose OX, OY, OZ OX, OY, OZ be three mutually perpendicular axes. Simultaneously, I am writing here also in the board. Let OX, OY, OZ be three mutually perpendicular axes mutually perpendicular axes. At O. Mutually perpendicular axes. We take two adjacent points, A and B. Suppose A and B. X, Y, Z, B, X plus delta X, Y, Z. These two points. Take two adjacent points. A, X plus Y, A X, Y, Z, and B, X plus delta X, Y, Z in the fluid. Take two adjacent points, A, X, Y, Z, and B, X plus delta X, Y, Z, B, these two points in the fluid. It is clear there. AB is parallel to OX. It is clear that AB is parallel to OX. Now, suppose I cap, J cap, K cap. I cap, this is J cap. I cap, J cap, K cap be the unit vectors along OX, OY, OZ respectively. Let I cap, J cap, K cap be the unit vectors. Along OX, OY, OZ respectively. Along OX, OY and OZ respectively. It is OX, OY, OZ respectively. Also let F factor, this is equal to X I cap plus Y J cap plus Z K cap. Be the external force per unit mass with the external force per unit mass acting at suppose A, acting at the point A. Suppose this one. Suppose P and P plus delta P, let P and P plus delta P be the pressures at A and B respectively. At A and B respectively. P and P plus delta P be the pressures at A and B respectively. We join AB and taking AB as axis, construct a cylinder of small cross section alpha. Join AB and construct a cylinder of small cross section alpha. We join AB and taking AB as axis. Taking AB as axis, we construct a cylinder of small cross section. Small cross section. We construct a cylinder of small cross section alpha. Now the fluid within the cylinder will be at rest under the action of the following forces. Now the fluid within the cylinder is at rest. Will be at rest or is at rest under the action of the following forces. Under the action of the following forces. And also PRO, yes, pressures at A and B respectively. Following forces. Under the action of the following forces. Number one. P is acting in this direction, P plus delta. Cross section is alpha. Now, pressure at A is P. Cross section is alpha. Thrust at A will be equal to P into alpha. The thrust P alpha at A acting along or along, you may write acting along or along. Along means acting along AB. Acting along. Number two, the thrust P plus delta P alpha at B acting along BA. Acting along B. Number three, external force F. This is the external force per unit mass. External force per unit mass. At A. The external force at A, F, per unit mass at A. What will be the mass? Mass is equal to density is equal to mass by volume. Mass is equal to volume into density. Suppose you multiply it by density rho. You will have to write volume. What is the volume? What will be the volume? Alpha into delta. It will be mass. it will be mass. External force demand along AB, where rho is the density of the fluid, where rho is the density of the fluid at the point A, XY, at the point XY. Number 4, the thrust on the curved surfaces. Thrust on the curved surface perpendicular to AB, acting perpendicular to AB. Thrust on the curved surface is perpendicular to AB. These are the curved surfaces will be like this, perpendicular to AB. Now, resolving the forces along AB. Now, resolving the forces. The forces along AB we get. Resolving the forces along AB we get. P alpha along the direction AB, P alpha. Along the opposite direction it will be P plus delta P alpha plus at the point A it will be the coefficient of I got x alpha delta x rho. Alpha delta x rho. This is equal to 0. Or you may write here delta P alpha. This is equal to x alpha delta x rho. Or you may write here delta P by delta x equal to rho into x. Delta P into delta x, rho into x. Or limit as delta x tends to 0. If delta x tends to 0, delta P by delta x equal to limit as delta x tends to 0, rho x. This means del P by del x, the partial differentiation will be equal to rho x. Similarly, del P by del y equal to rho y and del P by del z equal to rho z. Del P del z equal to rho z. Right? We have obtained this one. Now P is a differentiable scalar quantity. Now we go to dP equal to delta P by delta x dx plus del P by del y dy plus del P by del z dz. Del P by del z dz. It will be like this. Now this is equal to rho x dx plus rho y dy plus rho z dz. You may write like this. dP equal to this. This means dP equal to rho x dx plus y dy plus z dz. Which is the required pressure equation? Which is the required pressure equation? determines pressure of the fluid at the point AXYZ. This is the. You may write here P is a differentiable scalar point function. P is a differentiable scalar point function. Scalar point function of XYZ. P is a differentiable scalar point function of XYZ. Now, first let me remove this one. After removing this, we shall proceed. Now, we are going to discuss a theory. Before this, just let me. The pressure equation is, we have just found pressure equation is dP equal to rho x dx plus y dy plus z dz. The pressure equation is this. This pressure equation can be written as x I cap plus y z cap plus z k cap dot I cap dx plus z cap dy I cap dz. We may write it like this. Using dot product, you may write this is equal to x dx plus y dy plus z dz. This is equal to rho. It is nothing but f vector into dr vector. R vector equal to x I cap plus y j cap plus z k cap. This means dr bar equal to dx I cap plus dy j cap plus dz k cap. It will be like this. Therefore, the pressure equation can be written in this way also. The pressure equation can be written as in the vector form also. Pressure equation can be written in this form also. Suppose this is number 1. Number 2. If the force even be conservative, if the force F vector be conservative, let the force F vector be conservative with force potential V, then F vector is equal to minus gradient of V. Force potential is this minus gradient of V. Therefore, the pressure equation is, in this case, the pressure equation is dP equal to rho. F vector can be written as minus of gradient of V dot dr vector. You may write like this. Now, this means dP equal to minus rho gradient of V means I cap del V del x plus j cap del V del y plus k cap del V del z gradient dot I cap dx plus j cap dy plus k cap dz. This is equal to, this means dP equal to minus rho del V del x plus del x dx plus del V del y dy plus del V del z dz. V del z dz. Del V del z dz. This means dP equal to minus rho, it is dV, the pressure for a conservative force field, F vector. The pressure equation can be written like this: minus rho dV. V is the force potential. F vector equal to minus gradient of V. He is the force potential. Now, let me write the statement of the theory. Let me write the statement of the theory. What is the statement of the theory? The necessary condition for equilibrium of fluids means which is at rest, the necessary condition under the action of the force distribution XYZ the necessary condition for equilibrium of fluid under the action of the force distribution XYZ means what is the condition? To find the condition that the fluid may maintain equilibrium. Under what condition the fluid may maintain equilibrium? If the fluid is acted on by external force. And force distribution is XYZ means F vector equal to Xi plus Y vector plus X. What is the necessary condition for this? This is the let the fluid be at rest under the action of the force distribution XY under the action of the force is XYZ. Suppose the fluid be at rest under the action of the pressure equation. The pressure equation dP equal to rho x dx plus y dy plus z dz the pressure equation now be satisfied at all points on the fluid. Let the pressure equation vary be satisfied at all points on the fluid. Suppose this is number 1. 1 implies dP equal to rho x dx plus y dy plus z dz. This means you may write here delta p delta x dx plus del p del y dy plus del p del z. This is equal to rho x dx plus rho y dy plus rho z. This means delta p delta x equal to rho x, delta p delta y equal to rho y, delta p delta z equal to rho z. will be like this. Now, P is continuously differentiable. P is continuously differentiable. Therefore, delta to P, delta y, delta z equal to delta to P, delta z, delta y. It will be like this. Suppose this is number 2. Delta to P, delta z, delta x equal to delta to P, delta x, delta z. Suppose this is number 3. Delta to P, delta x, delta y equal to delta to P, del y, del x. It will be like this. Now to implies. From 2 you will get delta to P, del y, del z equal to del to P, del z, del y. This means del del y of del P, del z equal to del del z of del P, del y. It will be like this. It will be like this. Now, suppose this both this I am going to apply that del P, del z equal to del del y rho z equal to del del z rho y. This means I am writing here rho del z, del y plus z del rho, del y equal to rho del y, del z plus y del rho, del z. You will write like this. It is number 4. You will write like this. This means this means y rho del y, del z minus del z, del y equal to rho equal to z del rho, del y minus y del rho, del z. You may write this. This is number 5. Suppose this is number 5. Right? Similarly from 3 and 4 we get. Similarly from 3 and 4 we will get. Similarly from 3 and 4 we will get. From 3 you will get. Yeah. It will be y and z. And it is z and x. Is y. From 3 you will definitely get del rho, del z minus h, del h, del. You will get definitely this. This is equal to x del rho minus j del rho del. What will be this? Z. And it will be h. This is number 6. From 3 you will get this one. Number 4. From 4 you will get, it is x and y rho delta x minus delta y del y del x. This is equal to, it will be y del rho del 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 x minus h del rho del. It is x, it will be y. This is one mark. Comparing 5, we have written number 6 and 7. Comparing 5, we have written number 6 and 7. You see here how we have written this. Rho del y, del z, del z, del y. Yz. Next, you will have to write here zx, del z, del x. If it is del z, del y, it is del y. If it is delta y by delta z and delta z by delta y, it must be delta z by delta x by delta z. And it is z, here it is z. Therefore, you must write here x here. Del rho by del, here it is y. You will have to write here z. And here we have written y. For this, you will have to write here z. And del rho by del x, you should write here this del z. You should write here del x. Similarly, 7 has been written. Comparing 5, you can write 6 and 7. Very easy. Now, multiplying, now we see. Now multiply. Multiplying 5, 6 and 7 by x, capital X, capital Y, capital Z and capital Z respectively. And capital Z respectively. And then adding, we get x, rho x, you may write it rho x, del y, del z minus del z, del y plus this will common, take it as common. It is multiplied by y, del z, del x minus del x, del z. Now multiply this by z plus z del x, del y minus del y, del x. This one. Left hand side has been written. Now write the right hand side. This is equal to 5 is multiplied by x, therefore it will be zx del rho del y minus xy del rho del z, del rho del z, and it is multiplied by y, xy del rho del z minus yz, it is yz del rho del x, it has been written. Now plus it is multiplied by z, yz del rho del x minus zx, zx del rho del y, del rho del y. You see here del zx del rho del y, zx del rho del y will be cancelled. This will be cancelled. Xy del rho del x, xy del rho del z cancelled. Plus minus, this also will be cancelled. And this will be equal to 0. It will be equal to 0. This means x del y del z minus del z del y plus y del z del x minus del x del z plus z, you know, del x del y minus del y del x. This is equal to 0. This is the required necessary condition. Which is the required necessary condition. This is the required necessary condition. Which is the required necessary condition. This is the required necessary condition for the fluid. Necessary condition for the fluid to be at rest. Rest under the action of the force. Under the action of the forces. Under the action of the forces. External forces x, y, z. Under the action of the external forces x, y, z. This is the required necessary condition. Very easy to remember this. Capital X delta y by delta z minus delta z by delta y plus capital Y delta z delta x minus delta x delta z z delta x delta y minus delta y delta x. Very easy to remember this. Very easy to remember this. This is the necessary condition so that the fluid may maintain equilibrium under the action of the forces. Now, for a homogeneous fluid, this is the sufficient condition. Next theorem. Sufficient condition for a homogeneous fluid, to be at rest under gravity, under the action of the forces. Force distribution. X, Y, Z. The sufficient condition. We have to find the sufficient condition for a homogeneous liquid. Density is constant for a homogeneous liquid. Homogeneous fluid. Let the proof. Suppose there H delta y delta z minus del z del h del z del y plus y del z del h minus del h del z plus z del x del y minus del y del h. This is equal to 0. This is number one. To find the sufficient condition. This is suppose that this is true. Now the pressure equation is dP equal to rho x dx plus y dy plus z dz. The pressure equation is this. Suppose this is number. From differential equation, x dx plus y dy plus z dz, it is a perfect differential if the condition 1 is satisfied. From differential equations, we know this. By virtue of 1, by virtue of what? The expression means x dy plus y dy plus z dz is a perfect differential. By virtue of one, the expression, this is a perfect differential. Let it be du, perfect differential, let it be. That is x dx plus y dy plus z dz equal to du. It is, you may write here du. Why? Because one is satisfied. Because x delta y by delta z, it is satisfied. It is satisfied. From differential equation, since this is satisfied, therefore x dx plus y dy plus z dz must be a perfect differential. It is du. Therefore 2 implies. Therefore from 2 we get, yes, we write rho into du. This means P equal to rho u plus constant, integrating. After integrating, we get this P is equal to rho u plus c. Integrating, we get this. This means pressure equation can be integrated. That is, pressure equation can be integrated. Can be integrated. Therefore, the fluid is at rest. Therefore, the fluid is at rest. Is at rest. Thus, x delta y delta z minus delta z delta y plus y delta z delta x minus delta x delta z plus z del x del y minus del y del x equal to 0 is the sufficient condition. Is the sufficient condition. For a homogeneous fluid, for a homogeneous fluid, to be at rest under the action of the force distribution. X, Y, Z under the action of this process. Under the action of this process, this is the, therefore for a homogeneous fluid, this is the necessary and sufficient condition. Thus for a homogeneous fluid, x delta y by delta z minus delta z by delta y plus y delta z by delta x minus delta x by delta z plus z delta x by delta y minus delta y by delta x equal to 0 is the necessary and sufficient condition. Is the necessary and sufficient condition. Is the necessary and sufficient condition to be at rest under the action of the force distribution. Under the action of the forces. Force distribution or forces in X, Y, Z. force distribution actually. This is the necessary and sufficient condition. Dear students, in the evening I am coming again. At this time I want to stop here. Thanks for attending the class. Thank you very much.